Now we ask, if I put this thing at the 15 centimeter position, and incidentally, it doesn't matter if it's plus 15 centimeters or minus 15 centimeters, 15 centimeters above equilibrium or 15 centimeters below equilibrium, you're going to get the same thing. And when you reason it out this way, if you go below equilibrium and upward is positive, your force will be plus 18 newtons and your average force will be plus 9 newtons. But your displacement would be from 0 to negative 15 newtons. That would be a negative displacement. In any case, if F net equals negative kx, your net force is always opposite your position. Okay? So you always have negative work being done between the equilibrium and your position. So you always have positive potential energy, and that's manifested in the square here. Okay, well, your kinetic energy at 3 meters per second. Okay, where does that come from? Okay, well, you put this thing 15 centimeters above or below equilibrium, doesn't matter, and you give it a whack and you give it a speed of 30 centimeters per second. And it doesn't matter if it's down or up. 30 centimeters, or 3 meters per second. I had 30 centimeters per second, and that was a bad choice. It gave us a really small energy and didn't make the point. So we changed it to 3 meters per second. Okay, doesn't matter if that velocity is up or down. It doesn't matter if your mass is above or below equilibrium. Doesn't matter which side of equilibrium you are. You got an x squared here, so same on both sides. And kinetic energy involves the square of your velocity, so it doesn't matter if your velocity is positive or negative. The square of the velocity is what it is. So I said to give you a speed of 3 meters per second, not a velocity. Speed of 3 meters per second could be in either direction. Your position could be either up or down. So there are 4 possible cases. Position up, velocity up. Position up, velocity down. Position down, velocity up. Position down, velocity down. Position up, velocity down means you've got it up here and you give it a whack. Okay? And it starts down. Okay, it's kinetic energy, and you just get that from 1/2 mv squared. And the mass, I haven't written it in the board because it's in the document. The mass is 0.7 kilograms. Okay? So the kinetic energy, using 0.7 kilograms in 3 meters per second, is really easy to calculate. And we get approximately 3 joules, I think 3.15. Total energy at the 15 centimeter position then is what? Total energy is the potential plus the kinetic. It's 4.35 joules. Okay? Now, there's another question, but we'll stop here and then address that question.